In this video, we will learn about the Iterator design pattern and how to implement it using C++ code. Iterator is a behavioral design pattern. It allows us to traverse a collection of elements without the program having to expose the underlying representation of the collection. Many collections that we learned about, like lists and arrays, implement the Iterator pattern under the hood, which enables us to go through their elements using for loops and while loops. Let's look at an example of implementing the Iterator design pattern using C++ code. Up at the top of the program, we will include the vector header file. Then we will create a template of the types type1 and type2 respectively, using the typename keyword. Let's create a class named Iterator. Inside of here, we will utilize the public keyword and then type typedef typename for a vector holding type1 objects named Iterator type. We will also have a pointer to a type2 object named dataPointer and a variable of type Iterator type named dataIterator. Next, we will create a constructor that takes in a pointer to a type2 named initializationData, which sets dataIterator equal to or equal to dataPointer's container data's begin function. Then we will create a function with a void return type named first, inside of which we will set dataIterator equal to dataPointer container data begin. After that, we will have a function with a void return type named next, inside of which we will increment dataIterator. Then we will have a function with a bool return type named isDone, inside of which we will return true if the iterator is at the end of the collection, and false otherwise. Next, we will create a function with an iterator type return type named current, which will return dataIterator. I'm going to remove the space on line 8 so that the template line is right above the function name. After that, we'll create a template of class type1. Let's create a class named container, inside of which we will have a vector of type1 objects named container data. Then we will create a friend class Iterator, constructed with a type1 object and a container object. After that, we will use the public access modifier and create a function with a void return type named add that takes in one parameter of type1 named a. Inside of this function, we will add a to our container data vector using the pushback function. Then we will create a function that returns a pointer to an iterator named createIterator, inside of which we will return a new iterator and pass in the this keyword. Next, let's create a class named data. It will contain an int field named local data. Then we will use the public access modifier and specify a constructor for our data function, which defaults its local value to 0. After that, we will create a function with a void return type named setData that takes in one parameter, an int named value. Inside of this function, we will set local data equal to value. Then we will have a function with an int return type named data, inside of which we will return local data. Time to test our code. Inside of C++'s main function, we will create a variable of type container, which is made up of data objects named container. Then we will create some data objects. The first will be named element1 and will have a value of 1. The second will be named element2 and have a value of 2. The third will be named element3 and have a value of 3. And the fourth will be named element4 and have a value of 4. After that, we will add element1, element2, element3, and element4 to our container using the add function. Then we will create a pointer to an iterator named Iterator that we set equal to container.createIterator. Next, we will use a for loop that starts at iterator's first element, executes while iterator is not done iterating over the list, and moves the iterator to the next element each time. Inside of this for loop, we will output the data value of the current element the iterator is pointing to, and then a new line character. On line 65, we need to put a space between the two consecutive closing angular brackets, or we will get an error. When we run the code, notice that the elements 1, 2, 3, and 4 were output, meaning we successfully implemented the Iterator design pattern using C++ code. Great work. We use the Iterator pattern when we want our code to be able to traverse different collections, or when the types of these structures are unknown beforehand. Advantages of the Iterator design pattern are that it follows the single responsibility principle. We can implement new types of collections and iterators in our program without breaking existing code. We can iterate over the same collection in parallel, since each iterator object contains its own iterator state. And we can delay iteration and continue it when needed. Disadvantages of this pattern are that it can be overkill if our program works with simple collections, and it may be less efficient than going through the elements of a specialized collection directly.